everyone, welcome back to my YouTube channel. So for this week, I'm going to explain to you how you should answer test 2 question. So altogether, we have 6 different questions for this test 2, which consists of chapter 4 and chapter 5. So let's get started with the question number 1. In question number 1a, it states that the reaction of 1 mole of A and 3 mole of B will produce 1 mole of C and D each. In one reaction, 4 mole of A and 8 mole of B are placed in a 5-liter container and allowed to react to reach equilibrium. The resulting mixture is found to contain 0.4 molar of D. Determine the concentration of A, B, and C at equilibrium. So how are we going to answer this kind of question? So the first statement helps you to write the chemical equation. So it states here that 1 mole of A and 3 mole of B will produce C and D, of each having 1 mole. Right, so it means that you can write the chemical equation A plus, because here 3 mole of B, 3B will produce C and D, of which each one will have 1 mole. Alright, so what else are given in the question? It states here that in one reaction, 4 mole of A and 8 mole of B are placed in a 5-liter container. So when you want to answer this kind of question, instead of using the number of mole, you should calculate what is the molarity of the substance. Then only you can use that to put it in your ice diagram. So now we are going to calculate the molarity. So molarity, I'm going to start with A. So the number of mole of A given in the question is 4. So molarity is equivalent to mole over liter. So number of mole is 4 mole and it is being put in 5-liter container. So divided by 5, so 4 divided by 5, you should get the molarity of A is 0.8 molar of A. Alright, so you're going to do the same thing for B. So molarity of B is equivalent to mole over liter. So it have 8 mole of B and put in a 5-liter container. So 8 divided by 5 equivalent to 1.6 molar of B. Right. Okay, this is the first step that you need to do to answer this question. So what's the next step? You need to write the ice diagram. So in your ice diagram, you should have A plus 3B will produce C plus D. So you should have the ice diagram ICE. So the initial concentration, you already calculated it. So initial concentration of A is equivalent to 0.8. The initial concentration of B is 1.6. At first, there's no product is being produced, so 0 and 0. So at change, because you only have 1 mole of A, so negative X. Here you have 3, so negative 3X. So 1 and 1, so positive X and positive X. So remember that at the reactant, it always have negative because the reactant is being used to produce the product. So the product will have a positive sign. So at equilibrium, you shall get 0.8 minus X, 1.6 minus 3X, X, and also X. Alright, so then we need to look back at the question. The resulting mixture is found to contain 0.4 molar of D at equilibrium, right? So D at equilibrium, D is equivalent to X. So therefore, we can say that X is equivalent to 0.4. So you were asked to calculate what is the concentration of A, B and C at equilibrium. So at equilibrium, the concentration of A at equilibrium is actually 0.8 minus X. So since you know the value of X is 0.4, so 0.8 minus 0.4, you should get 0.4 molar of A at equilibrium. So moving on to B, the concentration of B is equivalent to 1.6 minus 3x. So 1.6 minus 3 times x, your x is 0.4. So you should get equivalent to also 0.4 molar at equilibrium. So what about C? So C is actually equivalent to X, whereby the X is 0.4 molar at equilibrium. So this is your final answer for this question. Moving on to question number 1, section B. At the start of a reaction, the concentration of N2, H2 and NH3 are 0.0711 molar, 0.0926 molar and 0.0873 molar respectively. The reaction was conducted in a 3.5 liter vessel at 375 degrees Celsius and follows the equation below. If the equilibrium constant Kc of the reaction is 120, predict the equilibrium direction for this reaction. So in this question, you were given the initial concentration of this reaction and you were given the value of Kc. So the thing that you need to calculate is actually the value of Qc. So the Qc, because given to you is the chemical equation, means that Qc is whatever in the product divided by whatever in the reactant. So I'm going to write what is Qc. So in the product you have NH3, so NH3. So remember, because you have 2 here, so NH3 to the power of 2 divided by the reactant, you have N2 and you have H2, but to the power of 3 because you have 3 around here. Okay, and then you look back at the question again. Given to you is the initial concentration of each thing here that you have. So the concentration of the N2 here, N2, H2 and also NH3 are as listed in the question. So I'm just going to plug in all these values. So 0.0873 square divided by 0.0711 times 0.0926 to the power of 3. So from here you should get 7.6213 times 10 to the power of negative 3 divided by 5.6455 times 10 to the power of negative 5, and therefore you should get your QC is equivalent to 134.9977. Right, and then we look back at the question given to you that the value of your the Kc. See, if the equilibrium constant Kc for the reaction is 120, so given to you Kc is equivalent to 120. So you can say that Qc is bigger than the Kc because this one is 134.9-ish and then this one is 120. Therefore, Qc is bigger than Kc. So when Qc is bigger than Kc, means that the equilibrium shall shift to the left, meaning that it will produce more reactant. So it shifts to the left. Alright, so this is the final answer for this question. Question number 1C. The hypothetical concentration of A, B, and C at equilibrium is 4.5 times 10 to the power of negative 5, 2.2 times 10 to the power of negative 2, and 9.4 times 10 to the power of negative 3 respectively. At STP, the reaction follows the equation stated below. By manipulating the concentration of A, B, and C at equilibrium, infer the equilibrium constant, the Kp, for the aforementioned chemical reaction. So given to you is this chemical reaction. So you have A plus 2B will produce C. Right. And then given to you is the concentration at equilibrium. So since you know the concentration at equilibrium, definitely you can calculate the Kc. So Kc is whatever at the product divided by whatever in the reactant. So we can say that C divided by concentration of A times concentration of B square because of this. Right. So all you need to do is that you need to just plug in this concentration inside this equation. So concentration of C is equivalent to 9.4 times 10 to the power of negative 3. Concentration of A is 4.5 times 10 to the power of negative 5. And concentration of B is 2.2 times 10 to the power of negative 2. So you need to have square over here. Alright, so from here you should get 9.4 times 10 to the power of negative 3 divided by 2.178 times 10 to the power of negative 8. Therefore, you will get your Kc equivalent to 4.3159 times 10 to the power of 5. Right, this is the first part of this question. So in this question, you were asked to calculate the Kp, not the Kc. So you are going to integrate the formula of Kc and also the Kp. So the formula shall be Kp is equivalent to Kc RT delta N. Alright, now the first thing that we need to do is to find the delta N. So what is delta N? Is whatever at the product minus whatever in the reactant. So we only have 1 in the product minus the reactant is 2 plus 1. So 2 plus 1. So it means that 1 minus 3. So 1 minus 3 equivalent to negative 2. So it means that your delta N is equivalent to negative 2. So now you are just going to get the value for Kp. So Kp is equivalent to Kc. Your Kc is this one, 4.3159 times 10 to the power of 5. RT, what is R? 0.0821. This is the gas constant times T. So what is your T? If you look at the question, it states here that at STP. So at STP, remember the temperature at STP is 27. So times 273. Your delta N is equivalent to negative 2. So therefore, what you should get is 4.3159 times 10 to the power of 5 times 1.9906 to the power of negative 3. So you should get 8.5912 times 10 to the power of 2. So this is the final answer for your question. Next up, I'm going to explain to you how you should tackle question number 2. So we are going to start with question number 2a. Chromium often is electroplated on other metals and even plastic to produce shiny metallic appearance. Determine the mass of chromium in gram that would plate out from a solution of chromium nitrate when 10 amperes of current are passed through the electrolytic cell for 5.36 hours. So how are you going to do this? You need to first convert the time from hours to second. So given to you is 5.36 hours. So this one you need to convert to seconds. So 5.36 times minutes times second. So you shall get 19,296 seconds. So this is the duration being used in this particular experiment. Next up, you are going to calculate the value of Q. So Q is equivalent to IT. So I is the current. So given to you in the question, 10 amperes of current is being applied. So your I is 10 and the time is this one. So it means that 19,296 seconds. So you will get the Q equivalent to 19,296 coulomb. Alright. So next up, you need to convert this coulomb to Faraday. So you know that 96500 coulomb is equivalent to 1 Faraday. Therefore, because you only have this much, so 192960 coulomb is equivalent to 1 over 96500 times 192960. So you should get is equivalent to 1.9996 Faraday. Alright, so what else that you need to do? So you need to look at this. So Cr NO3, right? So you need to calculate back what is the oxidation number for the chromium. So I've already done that. So Cr 3 positive plus 3 electron will produce the chromium, right? So it means that for 3 electron shall produce 1 mole of chromium. So the amount of electron is equivalent to the Faraday. So it means that 3 Faraday will produce 1 mole of chromium, right? And then now we have more than 3 Faraday. We have we have less than 3 Faraday. We only have 1.9996 Faraday. So how many mole of chromium that will be produced? So 1 over 3 times 1.9996. So you should get 0.6665 mole of chromium. Alright, but in the question you were asked to find what is the mass of chromium that will be electroplated out. So it means that number of mole is equivalent to mass over RMM. So the mass is what you want to calculate. The number of mole is 0.6665. The mass divided by the RMM. So you should be able to find the RMM from the list that I have given you in the question. So from that list, you should find the RMM for chromium is equivalent to 51.996. Therefore, this one times 0.6665. So the mass shall be equivalent to 34.655 3 grams. So this is the final answer for this question. Alright, next up is question 2b. From the chemical equation below, construct the half reaction equation and determine the inert cell for this reaction if the Kc is equivalent to 4.38 times 10 to the power of 10. So how are you going to do this? You need to know which one is the anode and which one is the cathode. So from here, we should know that the anode, and the cathode. So the cathode is the red cat. Reduction happens at cathode. So I'm going to write the anode first. So anode is equivalent to the zinc minus 2 electron that shall produce Zn 2 positive. So the cathode, so at the cathode is obviously the Fe. So Fe 2 plus 2 electron shall produce the Fe. Alright, so the question asks you to calculate what is the inert cell. So the inert cell is equivalent to 0.059 divided by N log Kc. Alright, so what is N? So you need to know here the N is the electron here. So we only have 2 electrons, so the N is equivalent to 2. So 0.059 divided by 2 log Kc. So what is the Kc? The Kc is equivalent to 4.38 times 10 to the power of 10 given in the question. So 4.38 times 10 to the power of 10. So your inert cell should be equivalent to 0.3139. So this is the final answer for this question. Moving on to the last question, question number 2c, given the electrochemical reaction are as follows. So these are the electrochemical reaction here. So if the standard reduction potential of Ag plus to Ag is positive 0.8 volt and the standard reduction potential of Cu plus to Cu is positive 0.34 volt, express the E cell for the following reaction. So from this question, the first thing that you need to look at is which one will undergo the oxidation and which one will undergo the reduction. So obviously here the copper shall go oxidation and this one shall undergoes the reduction. So you need to know, okay, which one is the anode and which one is the cathode. So the tips here is red cat reduction occurs at cathode. So we are going to write anode first. Anode. So anode is oxidation. So copper minus 2 electron will produce Cu2 plus, right? Because Cu2 plus, and then cathode. So you shall have the argentum. So it means that it undergoes the reduction. So argentum plus electron will produce argentum. So, but since you have 2 electron here, so you need to have 2 from here. So you shall get overall, or the net reaction shall be Cu plus 2 argentum plus will produce Cu2 plus 2 Ag. Right. So next up, you need to write what is the inert. So at the beginning, it states here that this is the standard reduction potential, but in anode, it follows the oxidation. So therefore, here, since the value is positive 0.34 volt, means that the inert is equivalent to negative 0.34 volt instead. But for cathode, it's okay, the value is the same, although you have times 2, but it will not change. So the value shall be positive 0.80 volt. So note cell. For this one is the summation of this anode plus cathode. So anode plus cathode is 0.34 plus 0.8. You should get equivalent to 0.46 volt. Alright. So the question needs you to calculate what is the E cell, not the E node cell, right? So the E cell is actually equivalent to the E node cell minus 0.059 divided by N log Q. So your E cell you already calculated 0.46 volt. So 0.059 divided by N. What is your N? The number of electron that is being used in this reaction, equivalent to 2 log Q. So next, what is log Q? So 0.46, 0.059 divided by 2 log whatever in the product divided by whatever in the reactant. So you have product is Cu2 plus, then here you have argentum plus, but remember, since you have 2 here, you put to the power of 2. So since you were not given the concentration of the Cu2 plus and also the argentum 2 plus, so means that this is the final answer for this question. So you shall end the calculation here. Alright, but if given to you is the concentration of the Cu2 plus and the concentration of Ag plus, means that you may plug in all this value here, so you shall get the actual value of the E cell. Alright guys, I think that's all for today's discussion. So thank you very much for watching this video. I hope you can understand all this question and how you should answer it. So I see you next week for the CQI sessions, and thank you very much. See you next week.